Okay, looks like the doors are closed here. So good morning, everybody. Thank you for coming to our session here. My name is Brad Pitzer. I'm the Director of Product Management for the V4 engine product with PTC. And again, we're going to be talking about augmented reality today and the perceptual shift in the game industry. It's great for me to be back here in Seoul. It's been a long time, over 10 years. But I had spent a lot of time here in the 2000s working with a bunch of Korean game developers where we developed, I don't know, at least 50-some titles on mobile devices back in the early days, at least for the US, the early days of mobile gaming. So, all right, so like I said, we're going to be talking about augmented reality. So what is augmented reality? Are there people in this room that have actually been developing augmented reality applications yet? Any hands? A couple. All right, so there's a few people, which is good. We're going to be kind of giving a little bit of an indication of what augmented reality is, all the different ways you can use it, the different contexts that it can be developed, and hopefully that will inspire you, like we inspired some of our developers back in the early days of mobile gaming, to start using augmented reality in your mobile apps and your mobile games, okay? So simply put, augmented reality is the idea of putting digital content into the real world, okay? At its core, AR grows out of the way that we humans process information. We access information through each of our 5 different senses. But it's interesting to note that really very little perception or information is perceived through the first 3, see if I can use that, no, a little bit, first 3 senses that are noted up there, taste, smell, and touch. And hearing itself is actually only about 11% of what we perceive information-wise. That means that about 83 to 90% of the information that we take in is with our eyes. So AR, or augmented reality, enables information, a new information delivery paradigm, which we believe will have a profound impact on the way we structure data and interact with it. Okay, oops, the wrong button there, sorry. So the effort required for us to transpose digital information to the physical space creates a heavy cognitive load. And so reducing that cognitive load, resources available for other tasks, mentally, so for an example, mentally understanding how GPS images and how they are perceived in the real world into the road ahead can be very demanding on what you're trying to do in the task. And it could easily lead to a potential accident on the road. And so, I keep hitting the wrong button, I apologize. There we go. But when we put that digital information so that the driver sees it directly connected to the physical world in which action is taken, this allows the driver to easily understand the information that is being presented without taking their eyes off the road, and thus being a lot more safer. Okay? So augmented reality works through what we call advanced computer vision. And this is really what makes augmented reality work. It acts as the eye for your application that you're developing. And so it takes the images that are coming through the camera or the visual piece of your device, and it analyzes those objects and or environments, and then allows you, the developer, to place digital content in that real world. Okay. AR, or augmented reality, powerfully magnifies the value of interacting with the real world, allowing your users to view and interact content within the context of their environment. We can allow them to visualize things. So AR applications provide sort of an X-ray vision revealing internal features that would otherwise be very difficult to see. So in the case of, let's say, we'll just use IKEA furniture as an example here. you can actually place, and many of you have probably seen this, you can place your IKEA furniture within your apartment, within your home, and visualize how that would look within the context of your space. Oops, one more. We can also instruct and guide users into how to interact with that content. And so it allows you to redefine how we provide instructions and manuals and brochures to people by allowing them to assemble things by projecting that digital information, those assembly instructions, onto the object itself, or the furniture in this case. Okay. So Vuforia Engine is an augmented reality software development toolkit that utilizes advanced computer vision. This vision is the eye of the application. It lets you see and understand the world through the device's camera and allows digital content to be placed within it. Keep going the wrong button, I apologize. There we go. Vuforia Engine is the most widely adopted augmented reality SDK out there. We have over 600,000 registered developers, and we're integrated in more than 60% of all augmented reality applications that are in the market today. That market share has actually gone down over the last, especially past year or two, due to things like ARKit and ARCore. But just know that we actually do complement those technologies by allowing you as the developer to kind of choose whether you're using Vuforia Engine or ARKit, ARCore in any given situation based on the type of devices that you're using, so that you can provide a consistent experience for your users no matter what device they're on, if it's a low-end device or high-end device. Okay. So Vuforia Engine is the market-leading AR development software. It offers unparalleled, make sure I'm on the right slide here. Sorry. Unparalleled accuracy for robust and reliable AR experiences, empowers developers to create freedom to build unique branded apps. So that's a very important part of what we do with Engine, is allowing you to actually create applications that are branded to your customer, to your IP, and allows you to offer the largest breadth of devices supported within the augmented reality community. Okay. Vuforia is a cross-platform, code once, augment everywhere. You don't have to target individual SDKs like iOS or Android. You can actually do everything from a single application and then deploy that across multiple applications or multiple platforms. This means that your app looks and works the same way across all your devices and platforms, including any head-worn devices such as the HoloLens 2. Anyone working with HoloLens yet? See one nod, a couple nods, okay, that's good. There we go, okay. Okay. So PTC's Vuforia offers best-in-class computer vision technology that revolutionizes the way we learn, communicate, and collaborate with others. It expands on human skills and efficiencies with power of AR. This is our suite of products that we currently offer within PTC, and we have new ones coming out or in development at any given time. Vuforia Engine is really the foundational technology for each of these different products. Okay, so anyone who's actually developed with Vuforia Engine knows that it's really just the computer vision part of any of your applications. We're using that same technology to develop other products within PTC, such as Vuforia Expert Capture, which is something that was actually just released within the last 2 weeks here. But it allows content creators and subject matter experts to quickly and easily create and distribute step-by-step instructions with rich media, content, text, and audio to improve workplace productivity. Basically what happens is you're walking around with a head-worn device, and it's recording everything that you do, and you can add steps and add content to that on the fly as you're walking through the space. The other product that we have that uses Vuforia engine technology is Vuforia Studio. And this allows content creators, again, subject matter experts, to efficiently author and publish scalable, immersive 3D AR experiences that provide frontline workers with the information they need to get their jobs done quickly, accurately, and safely. Again, these are can be very enterprise-oriented products, but it relates to everything that we do in Engine in helping us improve the type of objects we work with, the type of devices we support, and things like that. Lastly on this list is Vuforia Chalk, which is a collaborative markup tool. It basically allows us to make easy use of remote experts to provide kind of over-the-shoulder help and guidance in speeding up troubleshooting. So basically, you as the user on site something, you can call up an expert remotely, show them your scene or your environment that you're looking at remotely, and use augmented reality and markup to actually allow that expert to help guide you into troubleshooting a situation. Okay. There we go. Come on. All right. There we go. We're back. Okay, so there's many different ways to attach content to objects. We provide a very large target types that run kind of the full range of what you might be using within your augmented reality applications. These can go anywhere from view marks and image targets to providing scanned tracking on 3D objects. And then our most robust and newer feature is something we call model targets. Model targets actually use the 3D CAD models that are used to design certain products to recognize and lock onto an object within your environment. And it doesn't kind of stop there. We have some amazing things in development today, including enhancing each one of those different target types. We also have new features that we'll be introducing, as early as the end of this year. Something called train targets is another one, where we can track very large environments and allow you to put content in those environments to interact with. In fact, we met with a gaming entertainment company yesterday that could potentially use something like this to track content within a very large environment that they have. That's about all I can say about that. But it's a very interesting opportunities there. So to show you some examples here, using image targets and view marks is very simple. You put an image on the side of something, on the floor, in a poster, in a book, whatever, and when you scan that object, it will use that object to recognize and then lock onto your object and allow you to project augmented reality content to it. Additionally, probably the second most used target type is what we call ground plane or spatial targets. And what this does is it allows you to kind of scan the environment, find horizontal or vertical surfaces, and then allow you to place content on those surfaces. So this isn't necessarily locking onto a specific object or anything. It's actually just putting, in this case, a generator in the middle of the floor in this environment. And then lastly, our kind of most robust, again, target type that we currently support is what we call model targets. And this is actually using the 3D model of that generator to recognize, lock onto it, and then allow you to provide digital content in any form on top of that, which would be animations and images and steps, to do things to interact with. Again, this is by far our most robust feature that we currently have today, and allows for very great accuracy, especially compared to other target types that are out there. Okay. So here's some examples. This is a model target, and you see in this particular case, one of our iterations of model targets, you use a guide view. This kind of back to that. So you have this kind of guide view that allows you to figure out what angle that you should approach an object from. And once you've locked onto that object, you can actually project all sorts of different content onto that. Model targets enable objects to be recognized and tracked through the digital 3D model, the CAD model that was actually used to design this toy, or it could be a real car as well. By using these 3D models, it allows us to track much larger objects than we ever have before. We've kind of been limited to tabletop-sized toys and appliances and things like this. Now we're getting into full-size cars, aircraft, machines, all sorts of things are much, much larger than we ever have before. Here's another example. Again, the users provided a guide view. This is kind of the outline there. And it immediately recognizes that I'm looking at a saw, and then it snaps to that specific angle of the saw and allows you to continuously, as a developer or as the V4 engine works, it continuously kind of loops back to make sure that it's on track and as accurate as possible, to make sure that the user has the best possible experience. And here's another example where you can use guide views for multiple objects. So in this case, in the same application, we have multiple objects, and what we'll do is we'll go, as we go pan around a room or a table here, it'll recognize the different objects on that table or in the room and provide the digital content for those. So you can see how this becomes a very powerful tool. Okay. So something that we introduced the end of last year is what we call advanced recognition or deep learning model targets. And this is where we actually train the model or train the application through deep learning to recognize those objects in many different situations. And the reason I put this series of images up here, just to give you a sense of kind of what happens during the deep learning process, it takes my 3D model, which in this case is a car, and it puts it against millions of different backgrounds and millions of different angles, poses, lots of different lighting, different colors, different things, so that once it gets through the entire deep learning process, I can actually recognize that vehicle in many different situations. It might be low lighting on the street, or it might be inside of a showroom, it might be in a trade show. It could be in a whole bunch of different backgrounds, and it will know that it's looking for that specific car. Okay. And how this works, just at a very high level, I'm going to keep it pretty simple, is that we basically create model targets, through the deep learning workflow here, but we create these model targets, and they get sent up to the cloud, where we use a cloud service computers to actually provide that deep learning process. And we come out of it with a what we call a neural network file that you embed into your application, and it allows you to basically reference those models within your augmented reality application. So what's so amazing about this feature is that as we evolve it, we have lots of things still to do as it pertains to model targets, and really just any kind of target types. But what we can do now with this 360 model targets, which we have in kind of early release right now, is we can actually provide what we call truly markerless augmented reality. And so now I can walk up to any object that I've trained or done deep learning with, and it will recognize that object. Let's see if we can go back up. There we go. It'll recognize that object without any kind of markers, without any kind of guide views. It just knows where it is, looks at it, and then provides that snapped on digital content. Here's another example of what we call Model Targets 360. Again, this feature allows you to basically look at an object from any angle. And we currently have some of our customers in an early access program testing this out, evaluating it, and providing some great feedback. And it's actually become an incredible feature. We'll be releasing this June of this year. Okay. So let's see what some of our customers are doing with augmented reality currently today, and you can get an example here. So we already have some customers that are using model targets that I just mentioned. Lego has been a good customer in doing several things. They announced earlier this year at the New York Toy Fair that they would be putting out an application with a new Lego set called Hidden Sides. And basically it's a haunted house Lego set that will allow the users, once they've built these haunted houses or these different objects within the Lego set, to scan those with their phone. The model targets will snap onto the Lego objects or Lego houses themselves, and then it will provide all sorts of interactive content for the user to, I would say children, but the children to interact with. So in this case, there's ghosts coming out, and you have to capture the ghosts and do all sorts of things to interact with the environment, opening doors, turning things over to look for hints and objects and things like that. This is a good example with the type of customer that might use model targets, because in some cases we can really control what type of handset. I apologize, I'm going off the script here a little bit, but we can really kind of control the type of customer that has the type of handset they have in an enterprise, because we can expect that they might be using a high-end device. In this particular case, we don't really know what household objects or devices that people are using to interact with our Vuforia technology. And so we had to work with Lego to kind of come up with the best case scenarios on what happens if you have a very low-end device and you have very low detail objects like Legos. There's not a whole lot of detail to them. And what's the best case scenario? And really using model targets allowed them to have one of the most accurate experiences that they could have for this particular product. We have some pretty good expectations for this one. Okay. We also support external cameras. And this is basically using a remote camera. So it's a remote camera, not just your phone device, not a head-worn device, but actually putting an external camera on a robot, on a drone, on whatever. And you can basically enable a first-person view to interface within your app. Okay? So this traditional form factor of toys like remote control vehicles and drones, you can actually have a little bit more engaging interaction by adding a first-person view within these applications. Excuse me. And these new game elements can be added post-purchase. You can always actually be adding to this content. It's very dynamic, very digital, and you can always make sure that you're providing fresh content, which allows the extension of engagement of the toys with the user. Okay. Going? Yep. Here's another one where we have Mattel Hot Wheels, and the tracks are very simple, but they're very elaborate to build. But what's kind of nice about this particular application is you can point your device at it, whether it's an iPad or a phone, and it will provide very overlay kind of thrilling graphics and sounds onto the physical track itself, and provide all sorts of different games and other immersive interactive things that you can do on screen. Okay. This is an application that came out last year, and we're working on some new applications to do with their toys as well for this year, hopefully. Okay. And then here we have an augmented reality solution created by a developer that we use called Visionary 777. And they're one of our kind of key test beds when it comes to using model targets, but they create all sorts of applications. In this case, they use Vuforia Engine to optimize the dealership and auto shows for a cost-efficient way of allowing them to demonstrate multiple variations of a car in one physical, when only one car is present. So in cases where you might not have, in the US we have car showrooms that have hundreds of cars sometimes. In a smaller environment, you might just have a couple of cars, and this is a great way to kind of show all the different variations, different colors, different accessories, different trim levels, things like that that you might have on a particular vehicle. You know, previously this would require several cars or pictures in order to kind of convey this information. But this is a great way to kind of show that true customization. And again, model targets were used here, so we get some very good, robust tracking with this. We ended very quickly there. So I know, I don't know exactly what this says here, but I know if you fill out the survey, there's Starbucks gift cards in it. We're probably going to do a little bit of Q&A here, or yeah, Q&A. I think my slide deck here was a little bit short because I thought the interpretation part might slow us down a little bit, and I was wrong. So please go ahead and ask any questions. I believe there is a method of doing that with through the iPad, and then I can read them and try to interpret those. No? Okay. I'm not sure what you're saying. Oh, I don't know if maybe they didn't understand, but I was saying the presentation went short just because of the way I was trying to do the interpretation with the interpreter. So we're ready for Q&A. Yeah. And then questions should be on here, right? Okay. Okay, so the question was, and this is not necessarily a Vuforia related question, but I can probably address it as best I can. Um, the question was, when you are rendering 3D data basically on a mobile device in real time, how do you make it look as good as possible? I think a lot of you are used to pre-rendering a lot of the content that you use in Unity, and even baking textures and shadows and lighting and things like that into your models to make them look as realistic as possible, because you're not having to present those in real time. And the answer to that is there's a couple of different ways, but it depends on the type of application you're doing and what kind of device you think your users will have. If you know that everyone that's using this will have a high-end device, you obviously can take some liberties and add extra textures, do different things with lighting. But if you think as in Lego's case, that you don't know what kind of device the users might have, and you expect that they would have very low-end devices, you have to kind of develop to that lower common denominator, which is unfortunate as a developer myself to do stuff like that, because you really want things to look as best they can. So the key to developing the type of application that looks the best is really the preparation of your models is probably one of the most difficult things. A lot of times we get models that are millions of polygons and very large, and you're trying to render those on a low-end device. It takes a lot of optimization, a lot of hours to do that optimization of those models. And so I can't stress enough, to anyone who does, real-time applications, especially in 3D, that all the time that you spend upfront prepping those models will do amazing things for you in the end. It just it takes a lot of upfront work, unfortunately. There's no way around it yet. There's applications that do things. There's it depends on the type of 3D data that you have that don't always work. Sometimes you have to do a lot of that manually still. Okay. If we have a microphone. No? All right. I'll do the same thing again. Okay, so there's kind of two questions, and one of the things that's come up more recently with things like ARKit and ARCore is light estimation. And so the different OS-specific SDKs allow you to do different things with lighting. So some of them are just the temperature of the lighting. Some is directional, and then also to even just match the ambient lighting. So currently what we're doing in Vuforia is we're making those handles available to the user in those OS-specific SDKs so that you can do some of that light estimation. There's different types of lighting available right now. Currently, we're mostly just working with the ambient lighting and the color temperature of the lighting. There's actual directional and things like that we'll be implementing in the near future. The advantage of using Vuforia in conjunction with ARKit and ARCore and doing something like this is you have one kind of development environment that you can actually do that through. The other question was an example using Lego. How I think it was, how do you create an application using that model target based on the Lego set that you're building, I guess. Is that kind of the idea? And so the idea there, if you have an existing Lego set, so really Lego is providing this application as a product, a companion product for a specific set of Legos that they are selling. That specific set of Legos is called the hidden side in this case, but it could be, you know, an application for each of their different things. In this case, it's a haunted mansion that you build out. So it has to specifically be that haunted mansion, and it has to actually be built the way that your 3D model is expecting it to be built. So when you go and use a model target to do something like that, that model has to be accurate to the physical object. You can't have big variations in doing that, because otherwise it won't recognize it and it won't keep tracking to that object very well. So there are certain things that have to happen in that case that are kind of specific. You can have certain elements that are out of it. So let's say I have, in this case, like a haunted mansion, but there's trees and there's some other things within the environment. I might actually take those trees out of my model target, even though they're in the environment, and it might find those objects a little bit better, a little bit more optimized. It's one of those things you have to, you know, potentially play with to try, you know, what's best for the case. Okay. I don't see any questions on the iPad yet. Testing, testing. Are there any more questions? This way. Okay. Okay. Yep.
사실 저희 실제 뷰포리아를 사용해서 얼마 전에 개발을 했었는데 사실 최근에 가격적인 부분 때문에 뷰포리아 SDK를 사용을 못했거든요. 다른 SDK로 교체를 했는데 혹시 좀 중소기업이나 이런 회사들 같은 경우에 가격적인 부분을 조정이나 그런 계획이 있는지 궁금합니다. 네.
They recently used Victoria SDK, but it was so pricey, so they switched to another. He asked if there is a plan to support those like little companies or individual developers in the license price terms.
Yeah. So that's a good question. I don't know if you've seen in the forums, we've recently announced kind of a new pricing schedule, and we're going to be moving to a subscription-based pricing. And there's been a lot of questions about it, a lot of unhappy developers, you know, similar to yourselves that are maybe smaller design houses and things like that. And we do hear that it's becoming an issue, that it's becoming too pricey. At the same time, I guess our development is also becoming very expensive in some of the things that we're trying to do. But we would like to figure out a way to help, you know, to support, you know, developers in the type of applications that you're doing. And so maybe, you know, as a small development house and you're doing certain applications, it would be interesting for us to know, I guess, you know, are these applications that live long periods of time? Is it a 1-year application, a 6-month application, or is it 5 years or something like that? To maybe understand how we could support that type of license in a, you know, in an inexpensive way. We're currently still doing kind of a revenue-based type of pricing, I guess, based on how much revenue your company makes. And so we're trying to keep it as inexpensive as possible. But you know, we're doing our best. Maybe you know, instead of me trying to get into a whole pricing thing here, maybe at our booth later, if you wanted to come by, and I'd be happy to like chat about it and get some information from you. Okay. Okay. Oh, we got one more over here.
네, 제 질문은 저희가 뷰포리아를 사용을 하고 있는데 지금 빅포리아에서 그 어떤 특정 지점을 찾아서 AR 그 이미지를 띄울 수 있는 부분이 그 어떤 QR 코드를 이용하거나 특정 그 아까처럼 태깅이 있거나 아니면 미리 머신러닝을 통해서 사물을 인식시킨 다음에 그 해당을 매칭을 하고 있는데 지금 저희가 사용하고 있는 환경은 그 되게 좀 뭐라고 해야 되나 비슷비슷한 부분이 너무 많아서 머신러닝이 일단 어렵고요. 두 번째는 내부적인 그 생산 환경이 계속 바뀌기 때문에 각 해당 프로덕트의 그 QR 코드나 이런 태깅을 항상 붙일 수가 없는 환경이거든요. 그래서 좀 계속 고민을 하고 있는데 그 두 가지 이외에 또 어떤 다른 그런 기술을 적용할 수 있는 방법이 있는지 혹은 계획이 있는지 좀 알고 싶습니다.
So they have two difficulties. First one is the environment looks so similar, so it's hard to train the environment to recognize. And second one is the machinery or environment constantly changes, so it's hard to tag some QR code, for example. So if you have any suggestions or
Yeah.
or PTC has future plans for supporting those kind of
Yep.
difficulties.
So he's more of like an industrial enterprise type of scenario.
Yeah.
Okay. Okay. Yeah. So we have we're coming across this more and more often as we put this out into the industrial enterprise type customers, and factory floors all look the same. The machines all look the same, and things get moved around. People are moving. Forklifts and trucks and things are going everywhere. So we're fully aware of that currently, and we do have several products. And depending on what you're doing, whether they fit your type of use case or not, one, we are making constantly improving the model targets to make them more robust, to deal with changes in the environment, things that have been moved around, or doors have opened and things like that. So we're trying to be able to adapt to that type of scenario. The other option is something that we have coming out, and I very briefly mentioned it here, but depending on the type of environment you're in, we have something called terrain targets, which allows you to track and model basically very large environments like entire factories. So it's something that we'll be putting out here at in an early access or beta release in August timeframe. And we'd love to have contact somebody in the office here to get some more information on how you might be able to be involved in that early access program. It'd be interesting to see that. What was the second? Did I address both of the questions?
Yeah.
Okay. Okay. Move in here. The microphone.
뷰포리아에서 제공하는 서비스 중에 각 사용자들이 머신러닝으로 사물을 먼저 사전 등록해놓고 적용하고 있잖아요. 근데 각 사용자들이 등록해 있는 어떤 데이터셋을 전체 서버에 모아서 직접 등록 안 하고 다른 사용자가 등록한 어떤 데이터셋을 서버에서 제공을 하는 그런 걸 제공할 스케줄이 있는지 궁금합니다.
Basically, you provide them to make some data sets to train all the things, but he's curious about if we could provide other data sets generated by other users. Do you have plans for that?
How's that? So,
Machine learning,
what's that?
about machine learning, other data sets created from other users. Do we have plans to share?
How would that work? Where would the other data sets, or like who are the other users or the other data sets? I don't fully understand. Yeah.
질문을 하나 더 드리자면 그 데이터셋을 다른 유저들이 올린 거를 공유할 수 있는 계획이 있는지 그걸 물어보시는 거죠. Just asking
Mhm.
if some of this data archive,
Mm.
like training data,
Oh, gotcha.
are we able to provide those data from other users to one of them share?
I mean, we don't provide the service to share, cloud-based data. It's something that you could put together, like another person could put that together. We have an ISV, a customer currently right now that is taking in other users, their customers' data sets, training their model targets, and then providing that to other people. We don't do that. We just do the computer vision part of it, the augmented reality part of it, and that all gets brought into Unity, and they have their own database that stores that information for their customers. Yep. 5 minutes. Let's see. So somebody asked, what's the relation between? Oops. Moved. The relationship between Vuforia and Unity Engine. So if I understand this correctly, just so everyone kind of understands, but Vuforia is basically a computer vision or augmented reality plugin to Unity. So when you develop an application within Unity, you can bring in the Vuforia extensions to allow you to take advantage of the advanced computer vision features that you would have in an augmented reality application. So I guess there's two sides. With Vuforia Engine, you can build native apps without Unity, but I would say 98% of the apps that get built with Vuforia Engine are actually done in Unity. So it basically acts as a plug-in to that environment, an extension for augmented reality. I don't know if I answered that question properly. Can I recognize a building using model target features? So we've had some people do a few things like that. Buildings are still kind of at a very large scale, but we're working on doing some things like that. We have something that we have called extended tracking. And basically the extended tracking is once you've locked onto a very large object, you can start using things within the environment to extend the tracking as I move along. So as an example, I have a customer that does large aircraft, and they use the landing gear to snap onto their object, and then it recognizes the rest of the aircraft. And so they can actually move along the entire aircraft with that object, or with a device, and they don't have to be looking at just the landing gear the entire time. So there are ways to do that, but the building starts getting a little bit too big, at least at this point, for doing that. And that's kind of why terrain targets is actually being developed for those larger environments. All right, I think we're about done here. I'm going to go down to our booth after at the bottom of the escalator on this side, and if anybody has additional questions, I'd be happy to chat with you, and as well as some of our colleagues from the office here. Okay, thank you very much.